Hi everyone, I will walk you through our project to build a reliable law approval predictor, following the flow of our presentation. I will show you how we develop a classifier to predict law approvals. In finance, prediction is crucial. Our primary goal, as you can see on here, was twofold. First, maximize the ROC AUC score, which measures how well the model distinguish safe browsers from risks, and second, to ensure the model is robust and reliable for the real-world use. The key to reliability is presenting data linkage. To achieve this, we built an intelligent pipeline from the start. This means all steps like scaling data and handling class imbalance were contained within strict validate process. So let's ensure our model learn true patterns without cheating by picking at future data. The main challenge was the several class imbalance. We had many more non-defaulters than defaulters. A standard model might just learn to always predict safe, which is useless. So to solve this, we use a technique called SMOTE. As you can show on here, it creates a balanced and example for mentoring class. Let's focus on our module to genuinely learn the patterns of high risk um, browsers, not just ignore them. Next, we compare models. We start with a simple logic regression as a baseline. It performed directly, but our champion was the boosting classifier. As we can see here, is it complex architecture is excellent at finding interact nonlinear patterns in data that simply models miss, so which lead to a better score. And we can um, fine-tuned these champion models. We performed a search for the best um, parameters like limiting tree depths. This fine-tuning process is what pushing this performance to the peak on while keeping it from overfitting. But a high score on its training data isn't enough. We had to prove this model would work on new on-scene applications. So we use learning curves. These modules health report shown on here. These curves show two positive signs, low bias. Both training and validation scores are high. This means the module is powerful enough to capture the real complex patterns. And moderate variance, the small consistent gap between the lines means the model generalizes well. It's learned the signal without overly memorize the noise. So this module is well fitted and ready for the real world. Finally, accuracy alone doesn't make a business decision. We have to consider cost. So here the precision record change off, which translate directly to business outcomes. Focusing on high record means catching more actual defaulters. This minimize false negatives and prevent several financial loss from bad debates. Focusing on high precision means being very sure before approving a law. Let's minimize false positive and avoid rejecting good customers. So the beauty is that we can adjust a single decision based on the bank's current structure are more risky virus or more like growth um, oriented. So, big conclusion, as summarized on here, we followed a robust template for the real-world machine learning. Intentional pipeline architecture tackling optimization, leaking, provide validation, and on this confirmation. This give us more than just a accurate model. This give us a trustworthy business ready tool. So looking ahead, we could integrate external data like economy, trends, and set up monitoring for data drift to keep the model shape on time. And thank you for your watching.